The Pacific School of Science, Mathematics, and Technology has been a global leader in science, technology, engineering, and mathematics education for more than 30 years. The school has a mission to serve as a public residential high school, educating academically talented students to become state, national, and global leaders in STEM fields, and to advance public education across the state of Oregon. For the last 5 years, PSSMT has offered a specialized sequence or track of courses designed to prepare students to work in a high-performance computing research environment or research lab with a strong computational focus. The sequence is in the computational sciences, also known as modeling and simulation or scientific computing. 3 PSSMT faculty members currently teach face-to-face computational sciences courses. These courses include Honors Computational Biology and Bioinformatics, Honors Computational Chemistry, Honors Computational Medicinal Chemistry, Honors Computational Physics, and Honors Scientific Programming. Currently, the demand for enrollment in the PSSMT residential program far outstrips the supply of spots for students. Budgetary and physical space limitations have always been a barrier to increasing enrollment beyond the 650 students accepted into the residential program. In 1997, PSSMT started teaching distance education courses to various public school districts statewide via interactive video conferencing. Believing that an instructor is more likely to focus their attention on face-to-face students who are present in the same room, IVC courses have always been taught separately from traditional residential course offerings. Last year, the Oregon State Legislature approved capital funding to build a second residential campus about 200 miles to the east. PSSMT would like to start offering hybridized courses and conduct class meetings simultaneously to both residential campuses via interactive video conferencing, or IVC. Stakeholders are interested in finding a way to combine these face-to-face classes and IVC classrooms that will create a seamless, equitable classroom environment for both sets of students without compromising student experience or student performance in either setting. PSSMT currently employs school administrators, support staff, as well as instructional designers and support specialists. There are 3 dedicated faculty members in the area of computational sciences that work in the residential program. Although the 3 instructors in the computational science department are highly experienced subject matter experts, they have less experience with teaching and learning pedagogy. They tend to emphasize covering all the content over meeting clearly defined learning objectives. They are also accustomed to daily class meeting times, and although familiar with distance learning, they have not taught any distance education courses. According to Grant Wiggins and Jay McTee, Understanding by Design is not a prescriptive program, nor is it a philosophy of education. It is a way of thinking more purposefully and carefully about the nature of any design that has understanding as the goal. This model, also known as backwards design, is a 3-stage approach to designing instruction. These stages are identifying learning objectives, determining acceptable assessment evidence that the learning objectives are being met, and determining the knowledge and skills that students will need to know to perform effectively and to identify the materials and resources that will best meet these goals. The objectives of the PSSMT Course Redesign Pilot Program are to increase enrollment by utilizing backwards design principles to redesign face-to-face courses as hybridized IVC courses, create a seamless, equitable classroom environment for both residential and distance site students without compromising student experience in either setting, and introduce more PSSMT faculty to the principles of backwards design. In order to do this, we've developed a pilot program. Instructional designers have been utilized to work with instructors to revamp courses using a backwards design model and develop new teaching resources. This shift in assessment strategies has led to implementing fewer, more challenging assignments that align with higher-order thinking skills in Bloom's taxonomy. This has led to more active learning and less time spent listening to lectures or watching demonstrations. Hybridized courses have undergone a preliminary internal review based on the Secondary Quality Matters rubric. Quality Matters is a nationally recognized evaluation program for online learning that utilizes current research and is supported and practiced based on quality standards. IVC technology and equipment has been installed and tested at both campus locations. Teachers and students have been trained in Zoom video conferencing software and in the Canvas LMS. Teaching assistants have been hired and trained to serve a dual role of providing technical help to teachers and act as in-class advocates for IVC students by facilitating a back-channel communication during synchronous sessions. A classroom facilitator at the second campus has been hired and trained to handle any technical issues, facilitate communication, and serve as a testing proctor. By the end of this pilot program, 5 courses will have been redesigned using this backwards design model. 5 courses in computational science will be taught to 100 students at both campuses during the 2019-2020 school year. 12 to 14 synchronous sessions will be held weekly over the course of each semester, and a support plan for 3 instructors offering hybridized IVC classes has been developed. The types of questions we're going to look at in this evaluation plan are: how does the introduction of a hybridized IVC model affect student and faculty perceptions of teacher to student, and student to content interactions at both locations? How does teaching via IVC affect instructor attitudes about technology? If students are taught face-to-face and via IVC simultaneously, how do the experiences of students at each location compare? What are the unanticipated outcomes of implementing the hybridized IVC instructional model? What level of support and resources are needed to convert a face-to-face class in computational science to a hybridized IVC class? And what kind of technical problems are encountered when delivering the course to students at both locations? In order to gather data on our program, our Director of Institutional Research, along with her research associate, will design and conduct student and faculty surveys. Student performance on course assignments, activities, and assessments will be collected via Canvas, and correlations will be identified between end-of-course surveys and these student performance indicators. We'll also be conducting faculty interviews and student focus groups with both face-to-face and distance site students. We'll then analyze the transcripts to identify patterns, themes, and categories, with the goal of constructing a narrative detailing the faculty and student perceptions and attitudes around hybrid course delivery and related technology. Evaluators will also make observations of 4 classroom videos taken at different points throughout the semester. These asynchronous video recordings will allow evaluators to observe participants without affecting participant behavior. Our 2 evaluators will then prepare field notes with an emphasis on observing behaviors related to teacher to student and student to student interactions during video conferencing sessions. Data from these observations will also be compiled to allow for ease of comparison to information gathered in student and faculty surveys, faculty interviews, and both student focus groups, with the goal of identifying any gaps or inconsistencies in the data. Our hope with this formative evaluation is to help PSSMT make informed decisions about the best way to adjust, improve, and expand our program so we can impact and serve students all across the state of Oregon.